Okay, so in this video I'm going to talk about kinematics in one dimension. So you're going to see a lot of problems in one plane. The plane is either going to be in the x direction or in the y direction. Alright, so these are the kinematic equations, and before you use these kinematic equations, make sure that the problem that you're doing has a constant acceleration. Okay, if the problem does not have a constant acceleration, these equations will not work. Okay, so let's go over these equations one by one. The first equation says v, which stands for velocity, in the x direction is equal to the initial velocity. That's what this 0 means. v0x is the initial velocity in the x direction. The 0 is also called naught, so this could also be called v naught. Acceleration plus the acceleration in the x direction times the time. Okay, then the x's stand for, this is the initial distance and this is the final distance, plus the initial velocity in the x direction times the time, plus 1/2 the acceleration in the x direction times the time squared. Okay, this is the final velocity in the x direction squared, which is equal to the initial velocity in the x direction squared plus 2 times the acceleration in the x direction times the final distance minus the initial distance. And finally, the final distance minus the initial distance is equal to the initial velocity plus the final velocity divided by 2, and all of that multiplied by t, which is the time. Okay, so let's go ahead. I don't want to confuse you with the kinematic equations. I just want to go into the problem and you'll see how they work when we do this problem. Okay, the first thing you do when solving any physics problem is first read the problem. Okay, so that's the first thing you do. And it says a jet plane travels 420 meters on the runway before taking flight. Assume the plane has a constant acceleration. If the plane starts from rest and takes flight in 12 seconds, how fast is the plane moving when it immediately reaches takeoff? Okay, so one thing you should have noticed is that there is a constant acceleration, so you can use the kinematic equations to solve this problem. The plane is moving in the x direction, not the y direction. Okay, so that's why the kinematic equations are going to have an x here instead of a y. If the plane was moving up and down, this would be a y instead of an x. Okay, so the second thing that you want to do when solving a physics problem is right here, which I actually have it as the first step because I have them before you even read the paragraph. These are the steps to solving a physics problem. First, assign your direction. I always like to say that the right side is the positive direction, and I always like to say that the left side is the negative direction. Just like I like to say that up is positive and down is negative. Okay, you could do it however you want. You can make this the negative and this the positive, but you cannot change it afterwards. Okay, so that's the first step, assign your direction. The second step is to draw a picture. So here I drew a picture of the airplane traveling towards the right, and then it takes off into the air. Okay, so the airplane right here where it starts, it actually starts at a distance of 0, and according to the problem is going to continue on this track until a distance of 420 meters. This is where the plane takes off. Okay, the initial velocity of the plane is 0 meters per second. I know this because it says here if the plane starts from rest. Okay, so that's a keyword right there, rest. That means that the initial velocity of the plane is 0. We're looking for the final velocity of the plane when it reaches these 420 meters. We don't know what the final velocity of the plane is, so I can't write it down. I put a question mark. That's what we're looking for. We know that the plane takes off in 12 seconds. So 12 is the final time of takeoff. Okay, and the initial time is 0 seconds. Now in this problem, they didn't tell you that the initial distance is 0, but if they tell you the final distance, then you should assume the initial distance is 0, and you should have this written down in your problem in order to solve it. They also didn't tell you that the initial time is 0 seconds, but they did tell you that the total time is 12 seconds, so you should assume that the plane starts at 0, and then when you hit the stopwatch, the plane is going to continue all the way, and at 12 seconds the plane is going to fly off. Okay, and another thing that may confuse you in this problem is that they didn't really tell you that the initial velocity was 0 meters per second. You had to kind of decipher that by reading this part here that says that the plane starts from rest. Okay, so after you draw the picture, the next step is to write the givens. Okay, so the initial distance is 0 meters per second and the final distance is 420 meters. The initial velocity of the plane is 0 meters per second and the final time is 12 seconds. So now that we have the givens written down, we can the fourth step is to go back to the kinematic equations, and based on the givens that they give you, look for the kinematic equations that has the missing variable. Okay, and if you look at the kinematic equations, we cannot use the first one because we have two unknowns in the first one. We do not know the acceleration of the plane, and we do not know the final velocity of the plane. So we cannot use the first one because we have two unknowns. However, we can use the second one, okay, because in the second one we have the final distance, we have the initial distance, we have the initial velocity, we have the time. So we have all the variables with the exception of acceleration. So we can use this kinematic equation to solve for the acceleration, and after you solve for the acceleration, you can use another kinematic equation like this one right here. Is it this one? Yes, you can use this kinematic equation right here to figure out the final velocity. Or you can even use this kinematic equation up here, which is easier, to find the final velocity. Okay, so I'm going to start with this formula to find the acceleration. Okay, so we're going to have x final is equal to x initial plus v initial in the x direction times the time. Okay, I should have put here in the x direction, plus 1/2 the acceleration in the x direction times the times squared. Okay, so the final position of the plane is 420. This is the position where the plane is going to take off. So 420. Now I am not going to write the units until the very end in order to avoid any weird or long complications. Okay, the initial distance is 0, so this is 0, plus the initial velocity is 0 meters per second, and the time that it takes is 12 seconds. Okay, so 0 times 12, that's just going to cancel out because 0 times anything is 0, plus 1/2 the acceleration is what we're looking for, and the time we said is 12 seconds. We have to square that. Okay, so let's solve this problem. Alright, so I'm going to use the calculator now, and let's see what we get. Okay, so here we have 12 squared. I know that 12 squared is 144, and divided by 2 we get 72. So I'm going to write that down. 72 the acceleration in the x, so 72 times the acceleration in the x is equal to 420, and now I'm going to divide by 72. So the acceleration in the x direction is equal to 420 divided by 72. 420 divided by 72, and I get 5.83. So I'm going to plug that there. 5.83. Now I can write the units. I know that acceleration is in meters per second squared. Okay, this is the constant unit in physics. Whenever you're talking in physics term, meters per second squared is always the unit that you want it to be in. Okay, so now that we found the acceleration, I'm going to put that here in my givens. 5.83 meters per second squared. Acceleration is meters per second squared. Okay, so now that we have that, I'm going to use this kinematic equation because this one is easier than this one. So I'm going to use this one to find the final velocity. Okay, so it's going to be final velocity in the x direction is equal to the initial velocity in the x direction plus the acceleration in the x direction times the time. Okay, the final velocity is what we're looking for. The initial velocity of the plane is 0 meters per second because the plane started from rest. Okay, so this is 0. The acceleration we just found out to be 5.83, and the time is 12 seconds. So now we're going to figure out what is the final velocity of the plane. Okay, so it's 5.83 times 12. Okay, 69.96. 69.96 meters per second is the final velocity of the plane. Okay, and you could have used I did two steps. First I found the acceleration, and then I plugged it into this equation to find the final velocity, but you could have just used this equation from the very beginning and you could have just solved this problem in one step. Okay, so that's the end of this video. The next video is going to provide another example.